All right, number 9 from the CEMC work. A rectangular sunflower garden, I know how to draw rectangles, that's nice, is designed such that an area of 21 meters squared is fenced on all 4 sides. Okay. If the width of the garden is x, I'm going to make that the width. Determine the expression to model the total amount of fencing required. F as a function of x. So f of x, the total amount of fencing required. Okay, so I know it's going to be 2x, that's the width, and plus 2 times, well, sorry, what is that, did I say width? Yeah. And the length, let's call that 2L. But L, we know that L times X obviously has to equal 21. So we can say that L equals 21 divided by X. Alright, so f of x is actually equal to 2x plus 2L, which is 21 over x. Alright, we don't like to see rationals written like that. We need to get a common denominator of x, so we're going to have 2x. What happened there? 2x squared over x plus 42 over x. We'll just put them both over x like that. F of x. I prefer mine in factored form usually, but I like to have it in both ways. So this is going to be x squared plus 21. You know, that'll never actually equal 0 on the top, because x squared plus 21 can never actually equal 0. So let's see what this actually looks like here. And that makes sense, right? If x was ever equal to 0, there's no way you're going to have an area of 21 meters. X could be really, really, really small, and with L being really long, but x being 0 would never work. Right? So that's not going to be a thing. I better reread this question. So if the width of the garden is x meters, determine the expression to model the whole amount of fencing required. Oh, we just did that. There it is. This is, oops, I better not do that. Therefore, the whole amount of fence, you know what, I'm gonna be good. I actually have to post this later, so let's do something that's actually legible for everyone. Therefore, the whole, what were we asked again? The total amount of fencing required. The total amounts of fencing required. Total amount. I think they mean the total length. The total length of fencing required is given by, I'm going to cheat here, f of x equals 2x squared plus 21 over x. I just want to make sure that they're not telling me to use a different variable. Let's see. Yep, no, f of a function of x. That's perfect. All right, determine any asymptotes of the function found in part A and use a table of values to sketch the graph of the function. I would have done that anyway. Estimate the dimensions of the garden to the nearest tenth of a meter that will require the least amount of fencing. Provide reasoning. I probably would have done that anyway. Okay, so let's just do that. That's the fun part of this rational stuff, okay? We got x and f of x. Alright, so the top will never be 0, so we don't have any zeros. and you have yourself an asymptote at x equals 0, because that's when the bottom is going to be equal 0. All right. Now, what happens way off? Like this is a like a second degree polynomial on top and a first degree polynomial on the bottom. So I'm going to use the standard form to do my little division here. 2x squared plus 42 divided by x is, oh, let's do this right. You don't want to miss the 0x term, plus 42. So divided by x, you're going to get 2x. It's going to give me 2x squared. And you're going to get, so I guess I should put my, if I'm going to include all my terms there, I should put, oh, what happened there? Okay, so I guess I should put x plus 0, include all my terms there as well. So 2x plus 0, 2x squared plus 0x, and that's going to be 0, and that's going to be 0, so 0x plus 42. 0x plus 42 is just going to be plus 0. You get 0x plus 0 with a remainder of 42. Alright, so my asymptote is going to be at, let's make it purple, at y equals 2x. That goes through at the origin. Alright, and just to kind of give you a hint of where that would, like, let's say this is 10, comma, 20. Right, y equals 2x, so when x is 10, y is going to be 20. Right, so, and that's on the asymptote. I really shouldn't write that in on my graph because that makes it seem like that's a part of my graph. Alright, so that's the asymptote. What's going to happen? Well, let's plug in a number. Like as it goes, I know it's going to, okay, so we got asymptote here. Let's make it black. We know it's got to follow that asymptote. And it's got to follow this asymptote. And it's got to do the same thing below. Now, what does this negative mean? It's talking about the amount of fence. Well, you're not going to have a negative amount of fence for x. You're not going to have a negative length. So all this is kind of, all this part is all garbage. It's really the positive stuff that makes any sense at all. Alright, so here you go, and we need to estimate the dimensions of the garden to the nearest tenth of a meter that will require the least amount of fencing. Provide reasoning. And it says determine any asymptotes of the function and use a table of values to sketch the graph and the functions. So I really kind of cheated by not using a table of values, and kind of nipped me in the butt because it's hard to really tell where this bottom part is without a little bit of calculus, right? So let's test out some numbers. So you got x and you got f of x. Well, 0, it's undefined. Let's try 1. X is 1. You're going to have 22. You're going to have 44. When x is 2, you're going to get 4, 25, 50 over 2, so 25. When x is 3, you're going to get 9 plus 21, which is 30, 60 over 3, which is 20. It's getting smaller. X is 4. Let's see, you're going to get 16 plus 21 is 37 times 2 divided by 4. So 37 divided by 2 is going to be like 18.5. If I'm getting this wrong, I apologize. At 5, what do we got? 25 and 21. 25 and 21 is 46 times 2 divided by 5. So 46. I really should have been more prepared for this. 92 divided by 5. Oh, looks like the calculator's coming out now. 92 divided by 5. 18.4. Oh, we're getting close. It's still lower. Let's throw a 6 in here. So you got 36 plus 21 is equal to 57 times 2 and divided by 6 equals 19. Oh, it's getting bigger again. Alright, so I know it is somewhere in this region. Okay, it wants me to do to the nearest tenth. So I'm going to put that work on you guys. You're going to have to do the numbers like 4.9, 4.8, 4.7, 5.1, 5.2, 5.3. You're going to want to see exactly where this thing, I have a feeling it's going to be in the high 4s, but you're going to put all that in and you're going to see which one is the lowest, and you will have to the nearest tenth of degree. So there's a little bit of work for you guys to do at the end. Alright, I'm done with this video. The next question is obviously going to be number 11. So there you go. This was number 9.